Right, hello. How is everyone?
Hello.
Good.
Hooray!
Hello. Everyone's good. Nobody had a bad day? Everyone's up for it. This is great. Hello, welcome to London DevOps. Thank you all for coming. Everyone find the place all right?
Yeah.
Yeah? Good stuff. Yeah, I walked down from Liverpool Street and I think it's been many years since I last came down this way, and there's cycle lanes everywhere, so I almost got taken out about 17 times. Sorry, a bit of lack of planning there. So, London DevOps, meetup number 68. Who's been to all 68? I haven't been to all 68, I missed a couple to be honest. Dover almost, right?
Almost. Not quite.
Well, who's been here before? Who's been to London DevOps before? Yay! Yeah, some old guard, brilliant, fantastic. And who's here for the first time? Yay! Also brilliant. I love it when it's almost always about half and half, which is good because it's great seeing the old crowd, people who've been here forever, who we see all the time, wonderful, but also we don't want to get stuck in our ways, we don't want to talk to the same people all the time, so it's brilliant to see a good old mix of newbies and the old guard. Poor Mark. So, what's DevOps? Who's heard fewer than 100 definitions of DevOps this week? Anybody has, you're liars. Here's one of my favourite ones from Cambridge graduate ThoughtWorks. That's what DevOps is. That's another version of what DevOps might be. Giving enough of a shit to learn about your job, enough to learn about other people's pieces. So all the arts, not just your own little world. DevOps is about culture as well. Mandy Walls from PagerDuty now, sorry, wrote a brilliant book about building a DevOps culture. For a lot of people, DevOps is this. Who knows all these tools? Lies. Oh, there's always one. We like the infinity loop, though. You know, I live and breathe by the infinity loop. Getting into organisations and helping them make that into a loop. So we're not just building and deploying software and throwing it over the wall and forgetting about it. It's like we go back into continuous feedback. Using some of those tools. You're hired, by the way, if you really know all those jobs. So London DevOps, we've been going since
2013?
2014. Sorry, that sounded really condescending. Year on Alex. 2014. I think we've been going for in the present incarnation of London DevOps. And we've always had the same mantra basically, which is to get people together. God, it sounds like a dating app now. To get people together, share knowledge, meet new people, say hello to people next to you, people you haven't spoken to, make some new friends, to help each other out, and we'll have some talks, and basically everything that you hear will be shareable unless otherwise indicated. Nobody's ever said that they can't share something from one of these talks, except if we're at FACEBOK, but yeah, that still applies. So, we have a YouTube channel. We have got a little bit out of the habit of live streaming, so sorry if you're not here and can't hear me. Why am I talking to you because you can't hear me? But we've got all the recordings of all the talks, where there hasn't been a technical snafu for whatever reason, up on the YouTube channel, so please go and have a look there. The talks from tonight, hopefully, if my ancient camcorder works, will go up on the YouTube channel tonight. Always useful, especially if you're like me and your mind wanders a little bit and you miss a bit of the talk and you want to go back and review some stuff. Here's a code of conduct, standard code of conduct from Geek Feminism, which we utterly believe in and will enforce. We've only ever had to enforce it once. I'm very confident that tonight will not be the second time, but there it is. I'll just leave that there and have a sip of juice. If everyone read that, there'll be a quiz later. So here are the organisers of the group. So as I said, we've been doing this since about 2014. It's tempting to say that we know what we're doing, but we really don't. So if anybody has any advice, tips, if you want to do a talk, if you want to host, if you have a nice venue, venues as nice as this, big round of applause to Funding Circle for giving us brilliant venue tonight, right? Then yeah, please get in touch. Equally, if you want to do a talk, talks that talk to people, process, culture, tell you basically a journey that you've gone through in a DevOps way, or through DevOps tools, etc. They all really go down really well. So these are our 4 organisers. Mark unfortunately can't be here tonight. I'm that one, obviously. Jack, where are you? Say hello.
Hello.
There's Jack. And Alex is there being Stanley Kubrick for the evening. So yeah, as I say, any comments, any thoughts, wishes, desires, things you like, things you don't like, come and hit us up. If you're on the odd tweets, then there's our hashtag. So always good to get a bit of chatter going on Twitter. So hashtag London DevOps. So on to the sponsors. So this stuff doesn't happen naturally. These meetups, it does take a decent amount of time and effort to organise, and sometimes money as well. So we're generously supported by 3 or 4 companies. The first of those is Prism Digital. Alex, do you want to say a few words about Prism?
Yeah, DevOps and Cloud Talent Partner. So if you're looking to hire in the DevOps space, if you're looking for a job in the DevOps or Cloud space, we're here to help. And my colleague Rowan is here as well. So
say hello, Rowan. That's right.
Thank you.
Thank you. We're also sponsored by Adaptivist, who help out with technology and various other things. And WeShape. So WeShape is co-run by Jack at the back. So Jack, do you want to say a little bit about WeShape?
Yeah, hi everyone. We're a DevOps and cloud native consultancy. So we work with customers from technical advisory all the way down to project implementation. Some of our technical team are here. So Luke and Rob and a few other teams are here as well. So we're hiring for both perm and contract engineers. So yeah, enjoy the show. Good to be here.
Thank you very much, Jack. And we're also sponsored by Tyke, who do some quite brilliant API gateway services. Don't think we've got anyone from Tyke here, right? We keep inviting them, they keep not turning up, right?
Yeah.
Maybe one day. I know Riley's sending some books and things every now and again. There we go. So yeah, as I said, we're here very generously thanks to Funding Circle. And I need to hand over. Did you want to say something a little bit about Funding Circle, Mark? Do it during your talk. We had a little bit of a conflab about fire exits and health and safety earlier, and so if there's a fire, run. Sorry, fire exits are over there. Toilets are over there as well. Go to the second door that's marked toilets on the right out there, otherwise you'll get locked in. Me and Alex just got kind of locked in by a very furious cleaner. Which sounds way more. I wish I hadn't started this story. But anyway, I managed to get out. Okay, so the talks tonight. So we're going to have Mark. He's going to talk to us about the DevOps journey that Funding Circle have been on over the years, and then after that, the illustrious Mr. Hardie will be talking about observability and pillars. So that's it, really. Yes, tell us what you think. Come and accost one of us personally if you want to. That's fine. We don't mind. Feedback. There's this thing with a funny squiggly snail type thing. I think it's some email or something you can send if you really want to, with feedback or talk proposals or offers of cash or whatever. So yeah, do tell us what you think. Hope you enjoy it tonight, and we'll get on with the talks. Thank you very much.
I needed.
Oh, you need that?
Yeah.
Sorry. There's me trying to be helpful, being in reverse. Turn that off just for now.
Awesome. Can everyone hear me? No?
No.
You can't hear me, thanks. No. Ah, hello? Yeah, there you go. Awesome, thank you. As Mark said, I work here at Funding Circle. My name's Mark Hollands. I'm a senior engineer. I've done a few roles while being at Funding Circle, but I'm currently a senior engineer in the platform engineering team. And I'm going to talk today around our DevOps journey, what DevOps looks like at Funding Circle and the platform teams and the application development teams, but specifically around our adoption of Kubernetes and how we're starting to use Kubernetes to speed up application delivery, and some of the potholes we found along the way. So first off, I'll give a brief introduction into Funding Circle, what we do, and then kind of deep dive a little bit into engineering at Funding Circle. Obviously being a fintech, it's quite core to what we do. And then kind of look over what DevOps looks like, the teams that we all work as part of, and then deep dive into Kubernetes, what our Kubernetes infrastructure looks like, and how we're starting to use Kubernetes, as I said, to speed up application delivery. And then just give a bit of a teaser into some of the future DevOps related projects that we're looking into in the future. So, first of all, engineering at Funding Circle. But what is Funding Circle? So, Funding Circle, we're about 10 years old, just over 10 years old, and we provide financial products, loans primarily, to small businesses to help them achieve their goals. So, traditionally, it was providing term loans to small businesses. Over the COVID pandemic, we pivoted completely to offer coronavirus business loans that were government-backed loans. So, we've offered that for about 2 years. And going forward, we're going to continue on with our term loan products, but also look at new ways that we can engage with small businesses to help them achieve whatever goals they have. So as I said, we're a fintech, so tech is at the core of everything that we do. And there's a number of different teams that work within engineering here at Funding Circle. So we've got obviously application development teams. They work on the products and the applications that our borrowers, investors, and us at Funding Circle use to help people get their loans and their finance. We have data teams. A lot of what we offer in terms of our USP is enabled because of the data that we collect. So we have a lot of people working as data engineers to provide those kind of risk models. We have our DevSec team and InfoSec teams, obviously being governed by the FCA, where security is extremely important to us. So they kind of keep us honest with a lot of what we do here in engineering. And also there's platforms, and that's broken up into two teams, the core platform and SRE, and I'll go into a bit more depth in a second around what the function of those two teams is. So, as I said before, so we've got application developers, and we try and encourage throughout all of our application development teams adoption of DevOps principles. So we make sure that all the engineers within our application development teams can build pipelines and have the awareness and build reliability into our applications. But for some projects, obviously, they need a little bit of help from specialists in certain areas. So we have our SRE team that are a very clever bunch of people here at Funding Circle that can provide expertise on things like AWS or DevOps pipelines and everything in between. And then we have our core platform team, which is the team that I'm part of, and the people in the back row are all part of the core platform team. And we look at looking after all of our core infrastructure. So there's our Kubernetes clusters, our CI/CD pipelines, or our CI/CD platforms, our Kafka clusters, all the infrastructure that we use every day to host our applications. And it's the kind of the evolution that we've had in some of these core infrastructure technologies that I'm going to talk about tonight, and that will kind of show how we're speeding up delivery with application development. So before I do a deep dive on Kubernetes and how we're using Kubernetes, some of the projects that we've been working on over the last couple of years, we've worked on migrating Kafka from self-hosted Kafka. So a lot of our applications that we make here are relying on Kafka. It's the backbone of a lot of our applications. So we've moved from self-hosted clusters to Confluent Cloud. So cloud-managed clusters. We're unifying our CI/CD pipelines. So previously we were using Circle CI for application builds, application testing, container image builds, everything through to push into a container registry. And then we were using Jenkins to handle the deployment after we built the container images. But now we're unifying that with one technology, and we're using Drone with a little bit of Argo CD in the mix. And then container orchestration. So over pretty much the last year, we've really doubled down on moving away from our old container orchestration platform, which is Apache Mesos, which we adopted back in 2014. And over the last year, we've really started to migrate a lot of our applications to Kubernetes. So Kubernetes and what it looks like here, because this is kind of where we're diving deeper into how we're speeding up the application delivery. Our Kubernetes deployment, so we operate in 3 regions at Funding Circle. We operate in the US, the UK, and Central Europe. And we have a number of clusters in each of those regions. So we have staging and production in all 3 of those regions, and then some other test clusters and operations clusters in the UK as well. We also, for our cluster management, we are completely AWS pretty much here at Funding Circle. So we use the Elastic Kubernetes service on AWS and some of the technologies associated with that, so things like managed node groups. And then for monitoring and observability, currently we're using a number of different tools. So that's Greylog, Prometheus, and Grafana, and things like Honeybadger for application logs. And this is one area that we're actually looking at sort of moving forward with in the future, and unifying some of this on more of providing a single pane of glass for logging and observability. And we also want to build out some of our tracing capabilities as well. And then networking, we use Istio within our clusters for networking, so Ingress and some of the service mesh features of Istio. And all of this is managed using Terraform. So, what I'm going to do is kind of paint the picture of what it was like before, so say a year ago here at Funding Circle, and our deployment process and some of the pain points. And then I'll go on to what it looks like now and what we're trying to move towards. So what we had before, we have a very unhappy application developer in the bottom right-hand corner, bottom left-hand corner even, and they would then use, obviously, they would develop new features, use Circle CI to build the applications, to containerize them, and then push that to Key.io. And then that developer, once they were happy with their changes, they would go to Jenkins. They could deploy to a UAT environment, a test environment, and then they would manually deploy when it was their turn to staging, run some tests, and then manually approve so we can deploy to production. But using this kind of architecture and some of the pain points that we've had over the years is the amount of manual intervention that's required through all of this process. And a lot of the bottlenecks that we were finding was around people being able to do a lot of this at the same time. So it was very much bottleneck. We could only deploy to staging for each particular stack, one person at a time. So it was quite slow, the process that we had to go through to deploy changes. And this is a lot of the problems that we're going to try and solve. As I mentioned, we had a number of different environments in each geography for Mesos. So we had test environments, and then had staging, which is almost pre-prod, and then production. But the testing environments that we had were static, and they were multi-user. So there was a lot of contention over being able to test our application changes. So if we fast forward into what we're trying to build now, and what we've migrated a lot of the applications to, it's obviously the developer is now a lot happier, and we've, as I said before, we've unified our CI/CD pipeline into just drone, and a lot of the process is automated. So we can automate branch builds and pushing that all the way through to testing environments. We automate deployment to staging and automatically run tests. And for some of our applications, we even automate pushing it through to prod. For a lot of our applications, we still have a manual promotion to production. A lot of that's just to do around building the confidence in some of these technologies, and in the future we can change that and automate a lot more of that. As well as introducing drone, there's a few other technology changes here. So we've switched out Key, or we're in the process of switching out Key.io as our container registry for ECR, so kind of really focusing as much as we can on AWS technologies, and for a few other reasons as well. And we've also introduced Argo CD into the mix. So I said we've unified on drone. Argo CD is also in the mix to kind of do the mechanics of actually deploying the application to Kubernetes, and also making sure that the configuration that we have in Git is actually reflected in our clusters, and that having that reconciliation loop to make sure it's always the current version. We've kind of copied the staging and production clusters and what the tasks that those perform largely, but we've also changed the test environments, and that's what I'm going to do a deep dive into now. And we've switched out the old static test environments for a more sandbox contained experience for developers, so they can each have their own environments. And they look like something like this. So what a developer is able to do now is provision their own stack of applications, which is sandbox just for them. They can provision a stack of applications and any backing services. So say if those applications need Kafka or need a database, they can provision those in the same stack. They can run, the idea is that, very imaginative names here, app A2 and A3, for example, could be on the latest main version of a particular application, but they could switch out app A1 for a feature branch build. And then they could test in isolation their changes in this test environment and run any automated tests that they need. And Stack B also shows that obviously you might not want to have actual real running version of some of these applications, so for some of our stacks we're mocking out parts of the infrastructure. So if application Stack B was required to interact with Stack A, they could just have a mocked version of that instead. But the idea is that we're trying to remove that contention on our staging environments. So what we're aiming to do with this is shift a lot of that testing that would previously have happened in staging and shift that towards the developer so they could run it more frequently during their development processes using these environments, but also run it before they merge to main and before they reach the staging environment. So, a few lessons that we've learned along the way, a few technical ones, and I'll cover a few sort of more cultural ones in a second. The technical ones were around the use of our testing clusters, so we call them UATs, ephemeral UATs. The first thing that we found was when actually people started using these testing environments, we quickly ran out of nodes on Kubernetes. So we were setting maximum number of nodes in that cluster, as you do for managed node groups. We found that very quickly we hit those maximum limits. So a mixture of obviously increasing those maximums, but also our environments have got a time to live value set on them. So it was adjusting those TTLs as well, so to make sure that all the environments were cleaned up. So instead of running for say 3 days, these environments would run typically for about an hour and then cleaned up afterwards. So that kind of solved that problem largely. And one that we've had quite recently is the use of spot instances in AWS. So we found that as the cluster was growing and shrinking, we would find that nodes were actually being terminated because they were spot instances. They were being interrupted during test runs. So we've actually switched out a lot of the spot instances that we used to use on AWS, and we switched it out for on-demand instances. And then going forward, we are going to look at new ways that we can obviously get those cost savings that we were trying to get with spot instances. From a more cultural side, some of the lessons that we've learned is, and this is more just for the migration to Kubernetes, is education. So there was a lot of skill, especially in our platform engineering teams around Kubernetes, but trying to teach the rest of Funding Circle how to use Kubernetes, how to use Helm, what the new deployment looks like. So we're working on ways, we produced a set of labs that people can use, which are kind of like prescriptive guides about how to use some of these new technologies, but we're also looking about how we can better onboard people to use our platform. And from the other side, a lot of these migrations that we've been doing from Mesos to Kubernetes have been done by our SRE and core platform teams, and our awareness of what the applications actually do was sometimes quite lacking. So we've had to rely on our application development teams quite heavily to do these migrations. So going forward, obviously the documentation piece and our awareness of what our applications do, we're looking to solve those problems as well. In terms of future projects that we're looking into, so we're going to obviously continue our migration work, so complete our migration away from Mesos, but we're looking at adopting more technologies in AWS. And in particular, one that I've put up here and highlighted is migration to AWS Secrets Manager, and continue our migration to things like ECR as well. And then further adoption of some SRE practices. So we have, within core platforms, started to create things like SLOs and SLIs and error budgets for a number of our core services, so Kubernetes, Drone, and we want to, make sure that we have coverage of those, but also kind of tell everyone else in the application developers, development teams within Funding Circle that we have these SLOs, and start to encourage people to make SLOs for the applications they write. And actually start to question what reliability within all of the applications actually looks like. Cool. And that's me. So you can find me on Twitter at Mark J. Hollands, and if you want any more information about what I've spoken about here, there's a number of blogs. That's great.
Okay, anybody got any questions for Mark? Yeah, let's go to you first, Sid.
Yes, so I don't think I need a mic.
Do it for the tape.
Why? So you said you went to Kubernetes, but you're also using EC2 instance. Why didn't you just go the full flow and actually go on to use EC2 on-demand instances for your deployment rather than Kubernetes? Just curious.
So we were using. I may have misspoke during the presentation. So we're only using EC2 as part of the managed node groups. So it's only as worker nodes, and we're letting Kubernetes do all the orchestration of the containers. So using all the capabilities of Kubernetes, like the scaling, and making sure that it's highly available. All of those features of Kubernetes, as opposed to just hosting on EC2.
Well, you could do that with auto-scaling groups, right? You could also do that with auto-scaling groups, and I'm just trying to see your thought process there, like why you chose over for EC2 instance.
From our starting point, we were starting off from a point of having containerized applications on Mesos.
Right.
So that probably influenced a lot of our decision about migrating away from that platform.
Gotcha.
So there was a lot of the kind of configuration and the experience that we had using Mesos, and from that point of view, it was quite easy to make a migration to Kubernetes.
Okay.
So that's kind of was more the logical progression from where we were.
Okay. And sorry, just a follow-up question on that. Why would you use spot instances when you know they're going to go away if someone else bids for them? Why not just use on-demand clusters?
So
for testing purposes?
Yes. Yeah. So for testing purposes, so for production, we always use on demand.
Okay.
We've never used spot, but for cost saving, we trialed spot instances, and largely for a number of our clusters, we've actually found a lot of success with that. So for our staging clusters, we find that they're actually stable enough to be able to deal with spot. But we found with this EUAT cluster that there was a lot of instances when those were being taken away, especially during test execution as well. So if we had a long-running test that would take, say, 20 minutes or 25 minutes to run a complete test suite, during that time, parts of the infrastructure were going down.
And in that case, would you have used dedicated instances, which you had for longer, for example?
Yes. Yeah. So we switched back to on-demand for that. Yeah. I suppose it's more just the learning curve that we noticed that, and we've switched back to on-demand.
Right.
We're still quite open about finding other ways of solving that problem.
Right.
But at the moment, we're just acting to kind of stabilise the platform until we can optimise something else.
Okay, next question. Let's go a little further back. Sorry, this one to you first.
So you mentioned that you're looking into tracing products. Have you got anything specific in mind? And also, if you use Istio, it provides you good visibility of your infrastructure. what do you expect to solve with the tracing which Istio does not do for you?
Okay. Maciej, would you like to answer this, or should I have a go?
I'll answer
Go
that.
ahead.
No?
Okay, so yes. So phase one would certainly be looking at what Istio can provide. So first off, we were only really using Istio within the Kubernetes clusters for ingress. So we weren't using a lot of other features that Istio can give us. We have started to investigate, especially with some of our applications, about what Istio can give us. So that could, I think we were looking at Kiali to look for the tracing that Istio can provide. But I think we've been doing some spikes into OpenTelemetry and tying in, seeing what tracing capabilities there are there.
Cool. Okay, there's a question here.
So I guess you are using also a lot of more AWS services as part of EKS. So, and since you are managing that with Terraform, so do you guys have any kind of dependency on, for example, I don't know, what services are you running, but let's say API Gateway, whatever version that is basically dependent on some of the things that you deploy on the Kubernetes cluster, or on how you manage that kind of dependency between the infrastructure and the applications that you guys deploy on the Kubernetes services?
Yeah, so we do use a number of other AWS services. So things like we use RDS, we use S3 quite heavily. So all of the infrastructure throughout Funding Circle is all managed using Terraform. We do try and obviously break it up into logical areas. So we have specific projects for deploying the EKS clusters, and EKS is a bit of a different case as well, because we also have things like Argo CD that are handling deployments using Helm and things like that. But it's all managed through Terraform in various repositories, and we deploy that through Drone. Keep that up to date. Does that answer your question?
So I guess there's no dependency there.
We try. No. So I suppose there are dependencies. We try and keep it as self-contained as possible. So everything that one application is dependent on will be provisioned inside of that repo. So if we have an application that uses Helm to deploy to Kubernetes, the Helm chart is within that repo. And if that also relies on RDS or particular IAM users or things like that, the Terraform that would then provision that is within that repo. So we try and have all of the dependent services together within
Okay,
the
so
same
you
repo.
have the Terraform and the Helm, all in everything in the same.
Yeah, so for each particular application, obviously that isn't perfect. There are some overlaps. Some applications rely on other applications databases and things like that. Just like, especially with Kafka as well, a lot of obviously the topics are shared amongst applications. So we do have those dependencies, but as much as possible, we try and keep it inside the same repo.
What's your approach to security?
In what way?
In terms of working with Kubernetes, are you scouting your Terraform? Are you looking more from the platform angle? How do you approach it within your team?
So, I'm not sure if I completely understand the question. So in terms of, we manage security to the clusters. So we try and match the security access for the clusters to everyone's access to AWS. So a lot of the roles that people are given in AWS match what's in the cluster.
Yeah.
And then we have mechanisms if people require more access to elevate their access, but that's all audited if people require more access.
Yeah, so looking at access control. Cool,
Yeah.
Thank you.
Yeah, okay.
What was your question?
I was just going to ask about code build. As you're an AWS shop, obviously self-confessed AWS shop, did you consider code build, and why did you choose not to use code build?
I am not aware of us ever considering code build. Did we ever consider code build? Sorry for my naivety. What does code build do?
Basically like Jenkins.
Yeah, it's the AWS CI/CD.
Okay. Well, I suppose so we kind of not necessarily for that particular thing, but there's always the question whenever we decide on the technology internally, do we go, because we are very heavily AWS, do we go for the AWS solution or do we go for a third party? So there's a few examples of that. We use Confluent Cloud. We don't use the AWS managed Kafka. We also use, for a lot of our tracing within cluster, we use things like Prometheus and Grafana. We don't necessarily go native. So I think even though we are AWS, it doesn't restrict what we choose. We may choose other things.
Good stuff, good stuff. Let's go back. We're slowly going backwards. Some questions here.
Hi, thanks for the talk, very interesting. I have a question. How did you measure the result of this journey in terms of, I don't know, your developers being able to raise more features, less downtime? How did you measure this journey?
So we do measure the 4 key metrics for DevOps, which I can't remember, but it's so things like mean time to delivery. Those 4 key metrics, we have got dashboards that we monitor for those things. So trying to see how long it takes for a developer to deploy a change, and we are constantly monitoring that. So as we're migrating applications, we are checking that it does have an effect, and those metrics are actually driving what we're choosing to do next. So we can see through some of those metrics that it's taking us a very long time to deploy some of our applications. So for those applications, we're really questioning, well, what can we do to bring down those times? So it is something that we're monitoring, and certain members of the team can talk a lot more about it than I can.
Or just have one more and give Mark a break.
Okay. Question, you mentioned that Helm charts and Terraform files are part of the repo for the applications when they're deployed. So who actually creates and edits those Terraform files and Helm charts? Is it developers that work on the application or someone from an SRE team working in the engagement?
So it's very much a mixed bag. Some of our application development teams are a lot more independent than others. So we do have some teams that are very confident with a lot of these technologies. And they choose to do it themselves. Then there's a varying degree of SRE engagement to how much help they need. So sometimes we just need to be on tap to answer some questions about Terraform or about Helm, especially at the moment where people are still learning Helm. We're answering a lot of questions and sometimes do it for them. So there's answering questions, or sometimes our SREs will actually embed within the development teams and work as part of the team, learn the application and learn how to migrate it. So yeah, it depends on the team largely, but part of the purpose of SRE and the core platform team as well is to help out where we can.
Makes sense. Thank you.
Cool. Angelo.
We talked a bit about already selection criteria using hosted versus managed services, and you've used 2 other technologies. Obviously, you made a choice between Circle CI and Drone. I was wondering what kind of selection criteria you made there. And similarly, you've chosen Argo CD as your deployment tool. And was it just a GitOps decision, or was there more criteria? You can go for something like Flux or anything else? What kind of criteria did you use to make those choices?
Yeah, so I suppose for each technology there are different criteria. So for Circle versus Drone, a few reasons. I think we were looking at unifying the process so that using a technology that could handle obviously the CI part of it, doing all the tests, doing the container builds, but also do the deployment piece and actually be within our infrastructure, within our managed infrastructure. And what Drone is able to do, we're self-hosting Drone, so it can do obviously everything that Circle could do, pretty much-ish. But yeah, it can do that bit, but it's also within our infrastructure, so it can have access to the clusters if it needs to do a Helm, for example.
And now that Circle's got agents, would you consider, are you too far down the road, would you switch?
Never say never. So that's something I've actually only become aware of recently, is that technology. So that's where you can host agents within your own infrastructure, your self-host agents. Yeah, so yeah, never say never. I'd be interested to learn more about it, if nothing else. I think at the moment we probably wouldn't look to change. There's only so much that we really want to put our application developers through in terms of changing our infrastructure. It should enable application developers to do stuff, not cause them work to do. So I think there's a lot of change at the moment with adoption of Kubernetes and drone, but it's something I'd certainly be interested in.
Excellent. Great talk, Mark. Thank you. And brilliant responses to quite a lot of the questions there. That's really, really good. So let's give a big round of applause to All right, so let's move on to Mr. Hardie. Ubuntu. Alex.
Yeah, I like this thing.
We're there, yeah.
I used to have a lot of stickers in my old company on my laptop. People used to be like once I got a new laptop, a refresher, and I was like,
Just come back with the drinks and stuff.
Actually, good food go to waste.
Oh, absolutely. Good quality.
Even if it is stone cold.
All right, do you want to take your seats again and let's go on to the second talk? No? Okay, fine. All right, okay, so now I'll go over to Andrew, who's going to talk about more than 3 pillars of observability. Is that 4, 5, 7? All will be revealed, right?
Don't spoil my surprise.
Oh,
Okay,
over
thank
to
you. Thank you. So, my name's Andrew Hardie. Some of you have probably heard of me or know about me. I'm an ABC, another bloody consultant, and I do all kinds of things. Public sector, private sector, startups, fintech, been there. They didn't give any t-shirts though. So, I'm going to give a very simple overview of what is a subject that is more complex than is generally realised. You'll see as we go along. Those of you who are true experts in this, in the interests of clarity and succinct presentation, I have made some simplifications in here, so just kindly avert your eyes at the appropriate moments. Okay, so OLLI, observability, shortened to OLLI in the same way as you shorten internationalization to I-18N, dates back to 1960. It's control systems. You had control systems for industrial machines, which, funny enough, is actually where I started out in the industry. Control systems for industrial machines. So Rudolf Kalman wrote a famous paper about describing mathematical control systems, which then became control theory. The whole point is you're trying to infer the states of systems from their external outputs, things you can't see directly but have to infer. So there's stuff like that mathematics there. There was a friend of mine who is a mathematician. I was hoping to come tonight so I could go, you might understand this, because I sure as hell don't. Now, observability is a hot new thing, but why? Well, here are 3 very good reasons. Containers are black boxes. Kubernetes is a black hole. You put stuff in there and know not what happens to it sometimes. And service meshes are a complete black art. If you thought Kubernetes was complicated, wait till you dig into Istio. It's absolutely scary. And even scarier, now you run WASM code in your sidecars, in your Istio network. How do you debug that? Nobody's explained this to me at all. So, you can't or shouldn't be able to get inside those containers. If you're a good boy, you don't have a shell running in there that you can connect to. So, you only know what they tell you. Now that might be things they emit, or it might be answers to questions like, are you still there? How you doing? What's your metrics? And so on. Now, these are the 3 pillars: metrics, logs, and traces. Now, various vendors who've been offering this kind of thing for some time have suddenly now given this go faster stripes and called it observability. It's not, and we're going to explore why it's not. So, first problem with metrics is metrics are aggregates, they're not individual values. So it's an aggregate over a time period, 5 seconds, 10 seconds, a minute, a day, whatever, typically of a parameter that is itself an aggregate. Hello? CPU, memory, they're aggregates, and any one of 100 things could be contributing to a high metric value. The other one is correlation does not imply causation. So you can have an error rate that's rising, correlated with a traffic rate that's rising. That doesn't mean the error percentage is rising. It just means you're getting more errors because you're getting more traffic. And metrics and alerts are inherently reactive. You react after the event. Time series databases do naughty things. They're great for doing graphing, but they're not great for doing direct queries on, because they do compression, delta encoding, delta of deltas. So like that, they're a bit like Git. What you're storing is a series of diffs. Okay, so we've got our metrics, and we have alerts as well. But metrics and alerts both require prior knowledge. Why is this metric important? And why is this threshold important? Consequence, monitoring is for known knowns. You've got to know what you're looking for. Observability, on the other hand, is for the unknown unknowns. The fourth quadrant, unknown states. Not what happened, but why. The more complex systems we make, microservices, containers, Kubernetes, all that, the more ways there are for them to go wrong, other than the application itself going wrong. Fallacies of network computing, all that kind of stuff, plus complexities like your spot instance is disappearing or whatever. All kinds of complexities have seeped into what once would have been a straightforward, simple deploy. One of the fintech organizations I work for, which I won't name, they had a very simple deployment model. You write your code and you deploy it. It was COBOL going to an IBM Z series mainframe. Funnily enough, I was unable to complete the task I was assigned, which was to bring DevOps practices to doing that. There we are. So you're having to look at this from a different perspective. The steps between code commit and lighting up production instances of that code can be many, depending on how paranoid you are about testing, how careful you are about security, and how much you want audit signed in blood, because if you're a financial services organisation, you've got to have somebody who is responsible, who the lawyers can come around and grasp by the throat. Now, really important metrics. Perhaps these are the 4 metrics Mark was struggling towards, the ones from Dora. Dora's a Google organisation, I think. So this is not stuff you're going to fish out of Prometheus. This is the stuff that's the metrics about your whole DevOps, CI/CD pipeline. I have a favourite trick reverse interview question when I'm being interviewed as an ABC for a role, which is, what is the most important piece of code you own and operate? It's not your application, it's your deployment code. Because if your deployment code doesn't work, you don't have a business or a service. It has to work, it must have an owner, it must be fast, and it must be reliable. You need the observability in your CI/CD pipeline every bit as much as you need it for your running application because of that importance of that deployment pipeline. Lead time changes, deployment frequency, mean time to recovery, change failure rate. Some people add other things in there, but what you're really looking for is how well are the guys doing when it comes to converting requirements into code and converting that code into stuff that runs reliably. Logs, we've got logs. We stick them all in Elasticsearch, wonderful. And then people stick metrics into Elasticsearch as well and wonder why that doesn't go too well, because they've forgotten about cardinality. And then we get up to Kibana, result. No, not quite. Because again, you've got to ask questions that you have some idea of what you're looking for. You may not have that. Logs are usually unstructured and there's no context. It's a thing, right? A microservice produces this log. What called that microservice? There's no context. You've got no chain to figure out where it came from. And how do you correlate those? Well, if you ever do big data, you'll hear people talking about touch points, where one data set and another data set may have a single touch point, which is a single key that is common to both. So what are you logging? Platform logs, the stuff you might get out of VMs or instrumentation coming out of your provisioned Kubernetes. Deployment logs, yes, good. Your applications need to generate good logs. Mark mentioned OpenTelemetry. This is exactly what the OpenTelemetry project was created for. So it's tools, APIs, and SDKs which you can bolt into your code. All the popular languages are there. And you can just reference the library in the SDK and put in like a one-liner that will take care of all the communication to transmit a message out to a collector, receiver, whatever. That link there is an excellent read, and I recommend it to anybody who's interested in observability. Okay, really important logs. It's your CI/CD toolchain again. Auditable builds. Who built what and when? Again, if you work in an accountable industry like fintech, you need to know all this, and you need to keep that stuff for a startlingly long time. It's also true of transaction logs. If you're running a financial or a business system, you've got to keep this stuff a long time. And now, a most recent nasty killer thing, supply chain integrity. We all heard of SolarWinds and Log4j, but there's been lots of others. And you need observability to be able to go as far back as possible in your tool chains. Origins, what they pull in. The biggest one, of course, being transitive dependencies, not stuff you specify, but things that Maven, in its wisdom, decides should be included. Now, in all the brouhaha about Kubernetes 1.24, I think it was, that came out in March, deprecating the Docker shim so that you can no longer run Docker format containers in Kubernetes. The announcement that got missed was the fact that they've now settled on using SigStore as the framework for doing supply chain integrity. To me, that's a far more important announcement than the one about Docker shim. And there are systems you need which you don't have, which is up that supply chain. If Fred is found out to be a bad actor, where do I have code written by Fred running? If a repository is compromised, where do I have code running in my estate that came from that compromised repository? Stuff like that. There are almost no tools that do this. They'll tell you there's a vulnerability in layer 5 of container 47, but they won't tell you where it's running. You've got to make your own systems to do that. Okay, traces, the third of the pillar. Now, in those three pillars, traces usually refers to network tracing, which is simply putting timestamps onto the TCP headers as traffic passes through the various stages of your network and application components. So you can calculate the time delays, and what you're looking for is trending for something getting slower, and you can go and try and find out why. Jaeger and Zipkin are two of the best known examples, but they're network level only. What we want for observability are spans. Now what you can think of is a span as being like a network trace with a start time and an end time and as much else as you want in between. What you're trying to do is capture the activity for each step, component in the chain between request and response and all the bits in between, which may not be a linear chain because there may be multiple components operating in parallel to achieve a result. Each step or microservice creates one of these spans, and it's a linked list. You link it back to the parent span, right the way back to the origin, and that's how you keep the chain going. No blockchain here, by the way. And what you want is as rich a content as possible. The trace, metrics, logs, anything relevant, metadata. As much metadata as you can pile in there, because metadata is nearly always useful later. Platform application logs, the stuff coming from OpenTelemetry. What you're thinking of doing is like a multidisciplinary information capture. You're capturing stuff that someone who's doing debugging probably won't need or might not need. But you're going to have it there because these logs, well structured, and sufficiently rich can serve far more useful purposes than just debugging. That's useful, of course, but you can do a lot more than that. So distributed traces, think of those of a trace plus a span with that linked list with the span ID linking you back to the original root origin. Sometimes you can wrap these up structured so you make a root span that contains all the spans thereafter until the process completes. So you're showing what happens with the flow of the request and all the things that happen until the response is emitted and the process is done. Now we're getting closer to observability. Properly instrumented applications. Applications must emit signals, traces, metrics, logs. The definition is an application is properly instrumented when it's not necessary to add more instrumentation and code to identify or troubleshoot a problem. This is true of observability itself. You should not have to deploy additional tools or modify code to be able to discover what you're looking for. So, those of you who write applications should not just leave this to the platform layer to emit logs. Your code needs to emit logs, using OpenTelemetry for example, at every point that's important within the execution of the application. Now what's important, of course, is going to vary from application to application. You've got to decide. But something that could have a consequence is a good guide. You're either looking for something that is a record of audit type, we need to know this happened, and maybe who did it and when, but also a question of what happened for other downstream consumers of this valuable information. So my view, you write it, you run it, needs to be modified to you write it, you instrument it so you can debug it. Developers who don't instrument their code should be given a smack around the head and sent back to their IDEs to go and do it properly. Okay, oh look, I can't type either, sorry about that. So type of data records, cardinality, I mentioned this before. Cardinality, I'm sure you've all heard of it, but I put it in here for completeness. It's about the uniqueness of values. Me being a bloke, it's not very unique. There's lots of them here. My national insurance number probably is unique, although there are a lot of bogus ones floating about. A UUID is mathematically guaranteed to be unique to an extremely high level of probability. So UUIDs are probably, and possibly crypto keys, key pairs, are the highest cardinality things you can have. And why do you want the cardinality? Is because you can go, I want that and that one only. It's the selectivity that the cardinality gives you. But of course, high cardinality data gives you problems if you're trying to put this into an indexed store. Dimensionality, the number of keys. So if you're doing a JSON record, what you want is lots of key value, because the keys, the more dimensions you have, the better you can do correlation across different JSON trace instances. To look for patterns of behavior, that's where you're wanting to do the kind of stuff Darktrace does, but as an intrusion detection, but at an application and logging level. So you can do much better prediction than just looking at the trending of a metric. So basic rules, just catch as much as you can, as you don't know what you might need later, because this is to help you solve the unknown fourth quadrant problems. Storage is cheap, your time is not. Batching this stuff up and stuffing it into even a blob store, it's a lot cheaper than your time later trying to figure out what's happening. As I said, the more complex and distributed the system, the harder they become to instrument, simply because of the number of knots in the piece of string between starting and finishing. Monitoring does not equal observability. Please get this into your head. When people use the term monitoring, usually they're only talking about metrics and alerts and logging, probably in separate systems, Prometheus and Elasticsearch, and you access them separately when you're trying to look for something, and they call that monitoring. And my point, observability of your deployment pipeline is every bit as important as the running systems observability. So here's my fantasy design for this. Ship those structured records to Kafka. Mark using Kafka. Kafka is an amazing tool. Those of you who haven't used it, and I've had dealings with Confluent about their offerings. Basically what they're doing is Kafka with knobs on, especially handling things like upgrades. When you've got a cluster and you're trying to do a rolling upgrade across the cluster, don't try this at home, kids. Confluent is very good at that kind of thing. And I'm very impressed with Confluent as a company. They're not sponsoring me at the moment, and then once you've got their stuff in Kafka in different topic streams, so you can have different types of record or different origin points or whatever go into different topic streams within Kafka. If you're not familiar with Kafka, think of topic streams simply like an SQL database table, but it's a table that moves over time. You can only append to it, you can't delete or change, you can only append and delete, you can't modify or insert records. So it's very good for ordered records. And you could do cunning things like look at a record in one stream, do something with it, look up something, enrich that record, write it back into another topic stream, because it's a fetch model. It's not like AMQP or RabbitMQ where you're pushing the messages to a specified endpoint, and once all the specified endpoints have had the message, it's gone. In Kafka, the messages are retained. It's a pull model, which means you can have many, many processes looking at the same topic stream with negligible loading on the stream itself. That's how you build event-driven systems. I think that's what you're doing. Event-driven systems is a fascinating subject, but it's one of those ones that's really hard to get across to your C-suite because it doesn't feel like a database, and they go, but I don't understand. We all have that problem. Okay, Kafka, you process using various tools. I played around with Vector, which is a very simple binary program that allows you to do stuff in Kafka topic streams. Splunk obviously thought it was good because they bought the company. Apache Hop, most of you might not have heard of this. This is a relatively new Apache stable open source project. It's a data integration platform. So you can write stuff on a kind of write once, run anywhere principle that can either run in Hop natively, or you can run it in Spark, Flink, and all those other cool kid toys that I have yet had the time or the financial support to play with, but would very much like to do so. So, or Spark, Storm, Flink, Samza, there's a whole repertoire of things here that mostly come out of the Apache stable. And it has to be said, when you find a new project in the Apache stable, you're really impressed with how mature the product is when they first release it. There's some astonishingly good stuff in there. You can also run it in Google Dataflow or AWS EMR, I don't know what that is, for Beam, which is another Apache tool, and so on and so on.
Elastic MapReduce.
Sorry?
Elastic MapReduce.
Aha. Gosh. People still do MapReduce. Well, okay.
Apparently.
Fine. So, the topic stream concept, I've jumped ahead in what I was saying to my slides. Enrich the record in various ways, write it to a new topic stream. You can fire alerts off those, of course, because the process you have that's monitoring the records from topic stream can decide it's over a threshold and raise an alert. Rinse and repeat. The goal you're after is a topic stream of actionable intel. Here's the event, and here's some context to help you solve that question, problem, event, whatever. Not only for you, the poor Joe, trying to find out what happened and why, but also for auto-remediation systems, because you can provide far more context for an auto-remediation system than just a simple metric threshold. Plus, observability systems can do a lot more. So you have other downstream consumers that are not just the people doing debugging or platform engineering or SRE. BizInfo, because you can, if you've got good application logs coming out of your applications, you can do the BizInfo stuff about how many people are using our product, how many of them are using it in this way, how are they using it, the kind of stuff that helps with product design, product improvement, and client relations and engagement. Audit, as I've mentioned before, audit is becoming increasingly important, and managing the long-term retention of auditable records is a bit of an art in its own way. you want a system that allows you to offload that stuff onto a backing store. Kafka doesn't delete things unless you tell it to, so from that point of view it's great for keeping auditable records, but it doesn't do offload to backing store. The Confluent version does, but you could also use Pulsar instead for offloading to S3, for example, to keep those audit records you need to keep for a long time. Security. The kind of info you can get out of a good observability system helps security people in what they do, every bit as much as it helps your SRE team in what they do, and more. Basically, real observability is the way ahead. Now, being a good programmer, I have a README file, and this is it. These are the 4 books that should be on your list. I think everyone knows the Accelerate book. You read the Accelerate book, and then you give it to your C-suite, and you ask them to read it. If they come back to you and say, I don't understand, you tell them, go and read it again. Because what you want is them to understand why they need to give you the support to do what this book tells you to do, because that's how you can do a better job. The book is not a technical book. It's kind of a management process type book, explaining how you improve a software-based organization by the way in which you do your code building, code packaging, code deployment, and so on. The next one, Team Topologies, written by my mate Matt Skelton, is a brilliant recent book about how to organize your teams for maximizing the flow of work. There's a separate paper doing the rounds about how you can use Team Topologies approach to achieve something very valuable, which is reducing cognitive burden on the development teams. This is becoming an increasingly serious problem, contributing to burnout, people getting pissed off, dreaming of a simple job like cleaning windows and stuff like that, because the complexity of some projects is now so burdensome cognitively that it's difficult for you to do a good job. Site reliability engineering, the Bible from Google. Everyone who has anything to do with running anything should read that. And this is new, this one only came out last month, Observability Engineering, written by charity majors, who I'm sure you know, Mipsy Tipsy, from Honeycomb, and Liz Fong Jones from Honeycomb as well. Excellent book, by the way, highly recommended for anyone interested in observability. Right, that's it, enough from me. Questions?
Ready for that. Nice one, Andrew. Thank you. Questions? Anybody?
Cool. Nobody liked it.
No, I didn't like it. You got a question? Brilliant.
So, I don't think it's working.
Hold it closer.
So, is the way, so observability do you think is the way to feature where we are going, or where we want to go?
Yes.
But have you actually built any, or were in any project that actually have like a real observability?
Sad confession, no, because for the reasons I mentioned earlier, at the previous places where I worked that I explained this is what you need to do, they went, that sounds too complicated, or that might be costly, and stuff like that. Because like a number of other things that we wrangle with, they're actually quite difficult concepts to explain to C-suite as to why they have beneficial impacts on what you're trying to do. And it's not all about code velocity. We've all suffered this. Project managers, delivery managers, all they care about is code velocity. So all that happens is everyone just games the system in Jira and create bogus velocity. And you're not making better code. What you're doing is just technical debt, really. If all you're doing is velocity, you're just building a technical debt explosion to come later. Yeah. The company, of course, that is doing this really out there for real is Honeycomb. That is what they do. That's their business. Yeah.
He may not be sponsored by Confluent, but he's sponsored by Honeycomb.
Sadly, no.
Any other questions?
But if you know someone there.
Any other questions for Andrew? Yeah, we'll go here.
So on tracing, you mentioned Jaeger and
Zipkin.
But you kind of quickly dismissed it, like it's not because.
No, they're very good tools, but they're limited in what they do. They do strictly network level tracing. So at the TCP packet layer, They don't care what's inside the packet. All you're doing is timestamping the packet. It's like using a stopwatch on a train going between stations. That's all, but they do it very well.
No, I don't think it's only network. Even if you don't have network at all, it's still gonna go through all the classes, and it depends how you instrument your code. If you'll
But how am I wrong? It's TCP timestamps, TCP header timestamps. That's what Jaeger and Zipkin are.
So like there's another project called Apache Skywalking by the CO guys, and that does instrumentation. So you can.
Ah, so that's a different thing, or built on top.
So you can run your Java code with an agent library, and it actually analyzes your requests, and it looks at the call stack.
Yes.
And sends out the span as a call stack.
But I think I am right in saying that Jaeger and Zipkin only do TCP header timestamping.
I think Jaeger is like it's more simplistic, more basic, whereas Skywalking is the more fully featured.
Skywalker I haven't come across, didn't know about it. I only referenced that as illustrative of what you're doing at the network layer, which, as I said, is absolutely does not care about what's in the traffic. You're only measuring traffic latencies.
Yeah, I think they're quite new projects.
Okay, I'll go and have a look at it. Thanks for the tip.
If we use something like Jaeger, if we use something like Jaeger inside, for example, in Kubernetes with some service mesh, you're right. It's something like a TCP packet. We can just see the TCP headers from time and etc. But if we instrument in our code with the SDK, we can achieve more than TCP packets.
Then you're getting closer towards
yes,
observability, as I
very
described.
close.
But at the basic level, it is just TCP timestamping. Yes. Okay, good, I got that right.
Cool, excellent. Any more questions? Okay, I'm going to put one in there.
Cool.
Do you think...
Oh no.
Sorry. Don't worry, it's an easy one, don't worry. Do you think that since we've had like the Accelerate book, the DORA metrics, are people getting this stuff at the C-level more than they used to or not?
Of course, the answer is it depends. Depends where you look, and it depends who you've got at the C-suite level. The temptation is for C-suite to kick ass and take names to improve the velocity of the business. Well, they've got investors to satisfy, but bringing to market something that is brittle or broken by design is a far bigger hit on the investors than a bit of a delay. It's a delicate balance, of course it is. Why do we do DevOps? This is one that a lot of the C-suite get wrong. They think it's all about why you can develop the code and application faster. Well, it can help with that, but it's not the real reason for doing it. The real reason for doing it is to develop better code, because that deployment, build, test, ship pipeline needs to be reliable and above all, fast. Because what you want to do is have every code change built right the way through to production, tested all the way along the way. Because you want to minimize the distance between foul up and fix. You don't want changes hoarded to be deployed 4 o'clock on a Friday and the team bugs off down the pub. You want them to do the deployments, every deployment automatically, every time they make a code merge. Some tests, of course, you want pre-merge in case they're going to break the system. The more you automate that and the faster you make it, the better code quality you will achieve. That's in the Accelerate book, but there's also other stuff in there. But that's the true purpose of DevOps and all the hard work in making that pipeline fast, reliable, repeatable, all those good adjectives. The other problem you have with the C-suite, the other problem you have with C-suite level people is they conflate Agile and DevOps and think they're the same thing. This is another huge mistake. Agile is just a way of identifying, apportioning, measuring, and assigning human endeavor. You need no technology at all. You can do it with Post-it notes and crayons, and I've seen projects that ran like that. So long as you can all stand next to the same wall and see the Post-it notes, you'd be surprised it actually works. You cannot do DevOps without the complex and ever-changing underlying tool chain that makes it possible. My little joke about this is we now have reached a point unique in the history of computing where that CI/CD deployment toolchain is changing faster than the applications you use it to deploy. This has never happened before. And it produces unique challenges for the team working on it and huge challenges trying to recruit into that team, because you need people who actually thrive on change and not on doing the same thing for years. Okay, going back to the financial technology, a bank basically I worked before, with the COBOL code going to the IBM Z series mainframes, there were guys there who'd been doing the same job for 30 years. And the only improvement they saw in that time was to go from IBM 3270 green screen terminals to a 3270 terminal emulator running on a PC where they got colours. And that was the only change in 30 years of working. It ain't like that in our business. It's changing on a monthly, almost weekly basis. Now it's fun and it can be exciting, but it can also get in the way of what you're trying to do. And it requires that you have people within your DevOps team who work on your tool chain who are actually responsible for handling change. This is my controversial view, where everyone I've worked has told me I'm talking rubbish, but it's my view. You actually need someone to be in charge of monitoring, assessing, guiding and leading that change. Because if not, your tool chain fossilizes and it'll come a day when suddenly it doesn't work anymore. And another thing that is another one of my pet mantras is you need to test that deployment code every bit as much as you test your applications, because you are totally reliant on it. For example, run trial builds every night of, can you light up a Kubernetes cluster? Just light it up, does it work? Kill it off. Because cloud vendors have a habit of changing things. And although they may have told you in an email, you may not have seen it, or the bloke who should have seen it was down the pub or whatever, and suddenly you find the deployment doesn't work. You need to know before that happens if you want to deploy a fix fast. Of course, that's not a hot fix, because we don't do hot fixes anymore, do we, boys? We all commit from trust. And you want to know you can roll out a new deployment fast and know it will work, the deployment will work. I've probably said enough. It's a hint from nature.
So, a couple of months ago, you're right. Yeah. You've spoken so much, it's almost killed himself. A couple of months ago, we were at Jack's offices in WeShape, and I said, we were doing a panel, and I said something slightly provocative that triggered something in Mr. Hardie. And he then gave us a monologue, lasted about 5 minutes, about some of which was the basis for this talk. And I think I've accidentally just done that again, and boy was it beautiful. What else? Minimise the distance between foul up and fix. I want a t-shirt with that on it. That's brilliant. Ladies and gentlemen, we've heard some brilliant stuff here from Andrew.
Wisdom.
A big round of applause. Wisdom, yes, thank you. Can't wait to send the next one along into the talk. Okay, we're about done here now. So I just want to thank everyone who's come. Thank you for coming tonight. Big thank you to Andrew and to Mark for doing a brilliant talk as well. So big round of applause again to Mark. Thank you. Massive thanks to the Funding Circle folks in general, to Anthony, everyone else who's made the event a success. Biggest variety of beer and drinks and pizza and stuff I've seen in a very long time. So yeah, big it up for them as well, please. Thank you. That's it. We're going on our summer break now. I hope you get to have a break over the summer and do something fun. We'll be back. We've actually done really, really well, more through people being very generous than actual competency on our part in arranging venues for the autumn. We're almost all set. We've got September, October, November, I think, already booked in. So yeah, we'll be back in September. We'll be hosting it. That's a fairly big one, isn't it?
Things
I got my dates right. Yeah.
Are we allowed to say?
Yeah, it's a company called Meta. I'm going to be hosting this in September. Ooh, yes. So bring all your controversial opinions. We'll have a talk from someone who works on Meta, Facebook, Instagram, etc. And another. Also, October, November, all set up. So for venues, don't ask me to remember which one where we're going.
Well, we've got KPMG.
KPMG, right?
That's October, I know.
October. Are you KPMG?
Yes.
Hey.
Hello.
October, yeah. And November is the one we had to cancel.
Money Supermarket.
Money Supermarket,
Yeah.
So yeah, lots of good venues coming up. We do need talks. So again, if you've got a talk in mind.
You've had enough of me.
If you've got a talk
Although I have several ideas.
See, this is how it starts. Then do let us know. So apart from that, yeah, I'll shut up now. See you in September, hopefully, and thanks everyone for coming. Cheers.